We're going to finish this section by drawing the rest of these. We have 6 more amino acids to draw. And what I want you to do again is pull out your own sheet of amino acids so that I don't have to be flipping back and forth between them, so that we can be looking at the R groups together. So the first one that we're going to draw up here is lysine at a pH of 2. That's a low pH, so that means that we are going to see positive charges. Let's scroll back up to these refreshers. If the pH is less than 7, or if it's acidic, then we have positive charges only allowed. If the pH is above 7, if it's basic, we're only allowed negative charges. So lysine at a pH of 2, we can start by drawing the general structure of the amino acid without even knowing which one is lysine. We know that we have to have a COOH because we're not allowed to have the negative charge. The amino group is going to be NH3+. And now we need to go to our table of amino acids and see what lysine is. Lysine is one of our basic amino acids. So with basic amino acids, look at the R group on lysine. It's got a positive charge on the nitrogen. Our question now for us is that a low enough pH? Are we allowed to have 2 positive charges on the lysine amino acid? I would say, yeah, that's a really low pH too. So our structure is CH2 for NH3+. Moving on, our next one that we have is glutamic acid at a pH of 6. So that is also an acidic pH. So we're going to see positive charges on this amino acid. And that means we're not going to see negative charges. So we need to have COOH. We're not allowed to have COO minus. We're going to have NH3+. And what about the R group? Well, we can tell from its name, glutamic acid, that it is one of the acidic amino acids. But is that pH going to affect the R group? Look at the R group for glutamic acid, or it's also known as glutamate. And what do you see? You see a COO minus, but that is not allowed at a pH of 6, or we are only allowed to have positive charges. So our R group will be CH2, CH2, COOH. To get rid of that negative charge, you have to put a hydrogen on it. Histidine at a pH of 10, that's a high pH, so that's basic, so negative charges. So for our general structure of this amino acid, we're going to have COO minus, that's allowed. Instead of NH3+, we're going to have NH2. To get rid of the positive charge on the nitrogen, we have to get rid of one of its hydrogens. So what about the R group? Go looking for histidine. Whoa, that's a crazy R group. Look at that thing. So that R group that's one of our basic amino acids, and that R group has a positive charge on that nitrogen that's in the top corner of the ring, NH2+, and positive charges are not allowed at a pH of 10. So that means that our structure is going to be CH2, C, double bond, CH, N, double bond, CH, single bond to the nitrogen. Now, it says NH2+, but we have to get rid of that positive charge, and we do that by getting rid of a hydrogen. So instead of NH2+, it's just going to be NH. That's a tricky one. Glutamic acid at a pH of 12. That's a high pH, so that's going to be negative charge. That's a base. Let's start by drawing the generic part of this. So we have COO minus. That's allowed because it's a pH of 12. Instead of NH3+, we need NH2. And what about our R group? Let's go look for glutamic acid, also known as glutamate. Look at its R group. CH2, CH2, COO minus. Are we allowed to keep that minus charge at a pH of 12? That's very high. So yeah, we can go ahead and keep both of those charges. Now, if you're starting to feel like, oh, I don't know if I'm doing this on my own, if I'm going to be able to tell if the pH is high enough or not for both charges, I promise you, you will. The questions on sapling are going to be very straightforward. Histidine at a pH of 1, that's a low pH, that's acidic, so that's where we're going to see positive charges. So for the amino and the acid, we can have COOH, not COO minus. We can have NH3 plus. And what is the R group for histidine? Oh, that same guy again, histidine. So that's a very, very low pH, way low, which means that we can have both positive charges. So we can have the NH3 plus, and we can also have the positive charge on the R group. So we're just going to copy it the way that it is drawn on our table. NH2 plus, just like that. And our last one, methionine with a pH of 4, that's a low pH, so that's positive charge, that's acidic solution. So that means we will have COOH, we will have NH3 plus, and what about the R group? Let's go find methionine. It is one of our neutral, non-polar amino acids. Oh no, that's not true. It's polar neutral. So because it's polar neutral, the structure of the R group is not affected by the pH. So we just copy the structure down.